everybody has their warm-up all done correctly. This is how it kind of cooked down. I do want to talk about a couple of very interesting points of interest. If you have your red pen, I will definitely take it off of you. Thank you so much for being an expert for me. I do appreciate your time and your legwork and making sure we all did our warm-up correctly. Okay, the goal of today's lesson, just to be clear before I jump on into things, is to, all in all, we take care of, in this chapter, 4 methods for factoring. I'll say 4. Today we take care of 2 of them. One is the GCF method, and then the other one is special patterns. So those are going to be the 2 methods we take care of today. You folks might recall that factoring, quite simply put, is the opposite of foiling. They're sort of inverses of each other. So just to review, what you're going to be looking at with particular attention today are now problems that look like this. Let me step back for just a second. Not so much this guy, we'll take care of him tomorrow, but like this, we'll take care of today. This we'll take care of today, and this might be a problem in today's class. Our mission in today's lesson is very simple. These things highlighted in yellow will be our problems. We have to figure out how to get the answers, which would be, for instance, in part A, 3x times x plus 2. How can you turn those things into each other? So we're going to go backwards through the distributive property, and I'm also going to show you a way to stuff those parentheses based on the fact that sometimes we have some special patterns that occur. There is a common error, and it actually wasn't very common in this class, so I'm super pumped about it, to be honest. I didn't see a single I did see one person. I didn't see a single person in the room try to distribute that exponent into a set of parentheses. Whenever you have the quantity of 3, I don't think he was alone on that. I think, yeah, you're right, there's more than one. Look at you guys pointing fingers. That's funny. Yeah, that's funny. Okay, so yeah, you need to come to understand that you can't distribute an exponent into a set of parentheses when there's a plus or a minus. It's actually one of the biggest errors in all of algebra. So a lot of you did. You were programmed very well by your teacher last year. You write that as 3x plus 2 times 3x plus 2. It's a FOIL problem in disguise, so that's very, very good. So with that, let's get started with our 2 patterns for today. Like I said, the 2 methods for factoring we're going to focus on today would be the GCF method and then, like I said, special patterns that occur in the trinomials and binomials that we're going to see. The first method, the greatest common factor method, the GCF method. I teach it first because it is the method you have to try first on every single problem. So you always must try this method first. More or less, there are 3 steps to doing the GCF method. Step 1 is you must identify, like you did in your warm-up, the greatest common factor, or GCF, of all of the terms. Step 2, we do sort of like the distributive property in reverse. And then the last step, you check with the distributive property in FOIL. That's going to be how we check our homework tonight. So if you take a look at part A, the first step in doing that problem is to think about what the GCF would be for 6x to the, whoa, sorry, didn't mean to make seasick there. What the GCF would be for 6x to the third and 4x. And when I think about this, I first think, well, what are the common factors of 6 and 4? Does anybody know what the greatest common factor is for 6 and 4? Mom. It is 2. Very good. And then I look at x versus x cubed. And I think to myself, well, how many x's do they actually have in common? If you think about x against x cubed. Vince, what do you think? It is x. Very good. The trick, and Matt and I were talking about this, the trick for this is just to think to yourself, what's the variable that has the smallest exponent? So x to the first, that's a smaller exponent. That one there is a smaller exponent than this 3 right here, so that is my GCF. That comes to be a part of my GCF. Are there questions about the GCF now? We're all good? Okay. Now that's step 2. I open up a set of parentheses that sort of mirrors the original shape and size of the polynomial I'm trying to factor. And then I kind of ask myself, well, 2x, 2x times what would get me back to 6x to the third? And you could break that down into smaller bits if you would like. You could ask yourself, well, hey, 2 times what gives you 6? You guys know that, you're smart. 3. And then you have to ask yourself, well, x times what would get me back to x to the third? And that's x squared. I hear you. I do. I hear you. So 2x times 3x squared would get me back to 6x to the third. Bring down my minus sign. And then I ask myself, 2x times what gets me back to 4x? Do you know, JT? Sure. Or I just have a minus 2. I just bring down the sign. But you could have plus a negative 2. Now, how do we check? Again, you just kind of do the distributive property. So we ask ourselves, well, when I go to check, what I'm going to do is I'm going to ask myself, is 2x times 3x squared minus 2x times 2 the same as my original problem? 2x times 3x squared, that's 6x to the third for sure. And then 2x times 2 is 4x, and I have my minus sign in between. So I know that with the distributive property, I can check. This is a brand new note packet. Perhaps it's a good time to just take a minute because I see some things missing as I look around. Remember, what goes on the smartboard must go in your notes. So if I show you that I checked my work, you should also have that checked in your notes. If you don't understand what I'm writing, just stop. Put your pencil down, put your hand in the air. Say, Mrs. Lucas, you know, where did you get that 2? I'll probably ask, there's more than one 2 up there right now. So I'd probably say, which 2 are you talking about? If you're having trouble coming up with a question, like right now you're only maybe coming up with, I don't understand, Mrs. Lucas. We have these sentence starters over here. So how did you get this? Or why is mine different from this? Those are the questions you kind of want to ask. So it's a good time to review how to take notes in our Honors Algebra 2 class. Okay, let's do it again. Right here under Part B, I want to go ahead and factor out a greatest common factor. Here's a trick. I'm going to do the entire unit long. When my leading term, the term that has the highest degree or the largest exponent attached to it is negative, I pull out a negative GCF. That'll make tomorrow's lesson a whole lot easier. So do you see how the first number here is a negative 4? That means I'm going to try to pull out a negative GCF. So that's how this example is different than the one before. The process, however, is still exactly the same. So step 1, I need to identify the GCF of each of those terms. But I want a negative GCF. Very good. So, yes, I'm going to pull out a negative 4. Byron, I have a question for you, my dear. Why did you not pull out any x's? Yeah, very good. You can't pull out an x because it's not in every single term. Is everybody clear on that? It's not common. Okay. Right. So now in step 2, I open up a set of parentheses that sort of mirrors the original shape and structure of the polynomial I'm trying to factor. So I ask myself, negative 4 now times what? Like a fill in the blank in my head. Negative 4 times what would get me back to negative 4x squared? Nathan? Yes. And then careful with your signs at this point in time, because I'm asking myself negative 4 times what gets me positive 12x, JT. It would be negative 3x, nicely done. Because a negative times a negative gives you a positive. Does everybody see that? Okay, one more. Negative 4 times what gets me negative 16, Joe? Very good. So if I did my check, bless you, I would use the distributive property to do this. It would be negative 4x squared plus 12x, and then minus 16. And honestly, that makes me a pretty happy camper because this here matches the original problem. So I know I did that correctly. That is method 1 of 4 done. Does anybody have any questions about the GCF method? 0 questions. Thank you. Okay, next up. We have 2 special patterns that are going to show up on a quiz that's probably coming at you on Monday already. I know, right? A quiz like all the time. The next pattern that you're going to see is what we call a difference of 2 perfect squares. Quick, difference in math class. What does that mean? Subtraction, yeah, so look at all of these problems here. It's called a difference of 2 perfect squares because there's always a minus sign in between. Then if you'll look at either side of the minus sign, you have perfect squares, with the exception of part C. Remember, sometimes you have to do the GCF method first. So do you see, visually speaking, how this is defined? It's a minus sign with 2 perfect squares on either side. Okay, so the method I actually use to do this is something I call the square root method. I use it here, and I use it here. So for my special patterns today, you're going to see 2 types of problems, but they get done basically the same way. So here's how this works. To do the square root method, these problems I'm actually going to try to unfoil. So if you think back to your warm-up, the problems I'm now talking about from your warm-up are problems like this and problems like this. And what you might have noticed is the original problems there actually were stuffing 2 sets of parentheses. We foiled to get these as answers. So when I go ahead and I try to factor these, what you need to keep in mind is it's not going to look like the GCF method. We're actually now starting to stuff 2 sets of parentheses. We're trying to unfoil is what we're doing. To figure out what goes in those parentheses, I use what I call the square root method. So I'm going to square root here, and I'm going to square root here. I'm going to square root here, I'm going to square root here. Square rooting x squared. I ask myself, well, what multiplies to give me x squared, JT? Yeah, so that's going to be my firsts. The square root of x squared is x. So if I started to FOIL this, do you see what you get? X times x is x squared. You get that first term. Okay, now I have to square root 4. Square root of 4 is 2. So that's going to be your lasts, because the 2 times 2 would get me back to the 4. Notice if I FOIL this, I need my outers and inners to go away because there's no middle term. That tells me if I need my outers and inners to go away, I have to have 1 positive sign and 1 negative sign in my parentheses. Again, you check with FOIL. X times x is x squared. I have negative 2x and positive 2x. Those go away. And then positive 2 times negative 2 is negative 4. It all works. Okay, next one. Process is the same. I'm trying to stuff 2 sets of parentheses. So I ask myself, what is the square root of 16x to the 4th? Well, I know that the square root of 16 is 4. The square root of x to the 4th? Does anybody know what that would be? Ooh, I see a couple of you, Tom. It would be x squared. Very good. Because x squared times x squared gets me x to the 4th. Very good. The square root of 81, 9. What symbols go in between? Am I done? Am I done factoring it? Stephen, why are we not done? Do you know? Your instinct's probably like because you're all good at reading nonverbals, especially mine. But why are we not done, Tom? There's a difference of 2 squares hiding in there still. So we have to talk about this idea of what does it mean to factor completely. Do you see how I have a difference of 2 squares hanging out in there? It's no good. 4x squared plus 9, that's a sum of two perfect squares. We can't factor that. I'll tell you why in a little bit. Actually, a lot of it. We'll talk about when we go to graph parabolas at the end. So 4x squared plus 9, that's a sum of two squares. It's never going to factor. So we bring that down. I'm showing you how to factor now a difference of two perfect squares. I would square root this first part, square root this last part. Square root of 4x squared is 2x. Square root of 9 is 3. Put in a plus and a minus. So now if I FOILed and distributed all over again, I would get 16x to the fourth minus 81. Everybody see that? So what I'm trying to teach you in this case is sometimes you'll factor once, not be done yet. So if you have, what's tricky about factoring sometimes is knowing when to stop. Notice that I don't have a difference of two squares left over, and I can't take out a GCF, so right now this problem's done. Part C is a nice example. Ooh, what's up, Stephen? Like I said, I'm going to get into this a little bit more because the goal here is to be able to graph. You are all very funny. Okay, so 4x squared plus 9. Fun fact, that's going to make a parabola in a couple days. When we go to factor, the goal is to find a place where the parabola crosses the x-axis. Think back to what we did with absolute value functions. If I put a plus 9 on the end of a problem, that moves the graph up 9 spaces. Something I move up 9 spaces isn't going to cross that x-axis. So it's for that reason that that problem is not factorable. In general, we only factor a difference of two perfect squares, not a sum. Does that make sense? Okay. It'll make more sense as I go to like show you like how to solve. So, yes. Yes. How I write this? You can't factor 4x squared plus 9. That was what Stephen was just asking. You can only, for emphasis, we only ever factor a difference of two perfect squares, not a sum. Notice that sum of perfect squares is not in my list today. It's not a special pattern. That's important. Okay, last one of the day. It's the same method. We're going to use the square root method to do it. It just works out slightly differently. So if you take a look at part A, what you're going to notice again is that, oh, I forgot part C, sorry. Did you try part C? Some of you have it done already. GCF method first, you pull out the 3, and then we have 4x squared minus 1. This is now once again a difference of two perfect squares. So I'll bring my 3 over, and then I'm going to use my square root method on what's left. Square root of 4x squared is 2x and 2x. The square root of 1, that's 1. And then you have to put a plus and a minus in your parentheses. So always try your GCF method first, right? Kind of goes back to the beginning of our lesson today. Questions there? Don't write it down if you don't understand it. So if I FOILed, so I can check 2x times 2x, 4x squared. Outers is 2x, well, it's negative 2x. Inners is positive 2x, and my last would be negative 1. So that would give me this piece right here. And then distributing the 3 and would get me back to the original problem. So I know that this is legit. Okay, last one, perfect square trinomial. Again, comes at you in two forms. What's going to be important is that we're still stuffing two sets of parentheses. So let's show you how to stuff these. I'm going to go ahead and square root the first part and square root the last part. The square root of 16x squared is 4x. I heard it. The square root of 9 is 3. Now I have to think about what sign or signs go in between. So if I go to FOIL this, what do you think, Alex? Yeah. And we could write this, to be honest, the big kids write this as 4x plus 3 quantity squared. Yeah, you wouldn't write it out twice necessarily. You could be big kids and write it that way. Because 4x plus 3 times itself is just 4x plus 3 quantity squared. Okay, Alex, I gotta go back. Why'd you say pluses again? It's a, yeah, very, it's a positive 9, but if I put 2 negatives in there, that would give me a positive 9. Oh, you have some helpers. Megan, go ahead. Yeah, this would be a negative 24x. Very good, Megan. So 12x and 12x has to be positive 24x, so it's 2 plus signs in between. Word of caution, you should always very quickly check these with FOIL, because every once in a while, it'll be tricky on your quiz on Monday. I'll make this a perfect square and this a perfect square, but to make sure that you're checking your work, I won't make this 24, I'll make it a different number in between. So you gotta watch out for that. Part B. Oh, again, same thing. Do you see how this is a perfect square? This is a perfect square. I'm stuffing my sets of parentheses. The square root of x squared is x. The square root of 25 is 5. And then I just have to ask myself what signs go in between. Byron? That would make my outer and inner go away if I FOIL it, huh? Lily? 2 negatives. Get it, girl. Yeah, so x times x is x squared. We always check with FOIL. X times x is x squared minus 5x minus 5x. Do you see that, Byron? Negative 10x, and then negative 5 and negative 5. The product of those gives me positive 25. That is our lesson. Your assignment for tonight actually starts on the next page. Yeah, you don't have to go in your book. And you're actually going to start it right this minute. Right this minute. I will go ahead and let you know that your answers are on Blackboard, but who wants to go ahead and log in if they don't have to? Some of you have like sporting events and stuff after school. You're not going to be anywhere near a computer. So let's talk about how you check. FOIL. Very, very good. So I'm going to go ahead and give you some time to start on that now.